So till now we have studied about vector calculus. In the vector calculus we have studied about vector differentiation and second order vector differentiation. Also we have studied about three important theorems, divergence theorem, Stokes theorem and also theorem on gradient. Okay. So now we are going to study about elements of electromagnetic fields. That is the first chapter of the syllabus. Okay. So before entering into this syllabus, let me give an introduction about fields actually. So here we are going to talk about three kinds of fields in this electromagnetic fields. One is called as electrostatic fields. Second one is magnetostatic fields. Another one is electromagnetic fields. Okay. So first consider what are the fields we are going to study and what is the source of each field. Okay. So first consider the first field we are going to study is electrostatic fields. Electrostatic fields. Now I require what is the source of this field? What is the source or basic cause of this field? Okay. So you know that electrostatic fields are generated or produced by static charges or stationary charges. Charge which is not moving, that can produce a static electric field. Okay. So source is stationary charge. Stationary charge. The stationary charge means it may be positive charge or negative charge which is not moving. So a stationary positive charge can produce electrostatic fields. Electrostatic field E bar, or a stationary negative charge can produce a static electric field. Static electric field. So like this, a stationary charge can produce electrostatic field. Okay. Similarly, if we consider magnetostatic field, magnetostatic field or static magnetic field. Okay. Here, what is the source of static magnetic field? So here it is explained by Ampere. So according to Ampere, a current carrying conductor can generate magnetic field. When current flowing through the conductor, this current should be a constant current or a DC current. Then this current carrying conductor generates magnetic field. The magnetic field will be in the form of closed loops. The magnetic field will be in the form of closed loops. Okay. And this magnetic field direction is given by right hand thumb rule. Okay. So when you apply right hand thumb, here, thumb finger shows current flow direction, remaining four fingers indicates the magnetic field direction. Okay. So this is the direction of magnetic field. Okay. Thumb finger shows current flow direction, remaining four fingers indicates the direction of magnetic field. So this is given by right hand thumb rule. Okay. So now we can say that what is the source of magnetic field means a current carrying conductor. Current carrying conductor. Or we should add the term called as a constant current carrying conductor is the source of magnetic field. Okay. So now if you observe this one, what is meant by current flow? When current is flowing in the conductor, the meaning is that charge is flowing in the conductor. Flow of charge is nothing but current. Okay. So we say that charge is flowing here. Charge flows. Okay. So flowing charge in a conductor is nothing but current, which will produce a static magnetic field H bar. Okay. So here I said that to generate static magnetic field, we require constant current to flow in the conductor. If you want to make the constant current to flow in a conductor, the charge should flow with the constant velocity. When charge is flowing with a constant velocity in a conductor, that will produce a constant current. The constant current can produce the static magnetic field. So I'm going to say that. So constant current carrying conductor generates a static magnetic field, or we can say that charge flowing in a conductor. Charge flowing in a conductor with velocity constant. Or a constant velocity can produce the static magnetic field. Or we can say that, so the flowing charge or moving charge in a conductor with a constant velocity. When velocity is constant, what happens for acceleration? Acceleration is given by dv by dt, where v is a constant. So differentiation of a constant will become 0. Okay. So simply we say that, so a moving charge or charge flowing in a conductor with a constant velocity or a 0 acceleration can produce the static magnetic field. Okay. So finally I conclude here. So simply moving charge with velocity constant or acceleration 0 can produce the static magnetic field. Okay. So this is the source of magnetostatic field. Similarly, we consider the third field. Third one is electromagnetic fields. Electromagnetic fields. Yeah. So here already we studied for a static field, a stationary charge is required. For a magnetic field, a moving charge is required with a constant velocity. For electromagnetic fields, so we require a time varying current through the conductor. Okay. So the source is time varying current through a conductor or in a conductor can produce the electromagnetic fields. Or whenever the current is varying with time, what happens for a charge moving in a conductor? So charge moving in a conductor will move with some velocity. Whenever velocity of the charge is varying with time, then current through the conductor also varies with time, which will produce the time varying magnetic field. Time varying magnetic field can produce the time varying electric field. Like this, electromagnetic fields can be generated. Okay. So here we say first cause is time varying current in a conductor can produce electromagnetic fields, or we can say that moving charge with time varying velocity. Time varying velocity in a conductor can produce electromagnetic fields. Okay. So here velocity of the charge varies with time. When velocity varies with time, then what happens for acceleration? Acceleration is given by dv by dt, where velocity is varying with time. So acceleration is non-zero. Acceleration is non-zero. So simply we say that accelerating charge in a conductor can produce electromagnetic fields. Okay. Is it exactly acceleration? Let me explain. When acceleration is non-zero, we have two choices. Acceleration is non-zero but a positive value, or non-zero with a negative value. Okay. Whenever acceleration is non-zero and positive, then we say charge is accelerating, or there is an accelerating charge. Accelerating charge. Whenever the acceleration of the charge is non-zero but a negative value, then we can say that it is a decelerating charge, where velocity is decreasing. So when velocity decreases, it is called as a decelerating charge. Okay. Decelerating charge. So now we can say that accelerating or decelerating charge in a conductor can produce the electromagnetic fields. Okay. Sometimes whenever current is a sinusoidal current, whenever current is a sinusoidal current like this. Okay. So whenever current is increasing from 0 to maximum, this will result when charge is accelerating. Okay. So the current will decrease, current value will decrease from maximum peak to minimum peak when charge is decelerating. Okay. Again, minimum peak to this maximum peak when charge is accelerating. Okay. So when charge is accelerating, you get the positive values are increasing current, and when charge is decelerating, we get a decreasing current. Again, charge is accelerating, increasing current. Okay. Here what is happening means repeatedly charge is accelerating, decelerating, accelerating, decelerating, and so on. Okay. So simply we say when this process is repeated continuously, charge is accelerating and decelerating periodically, then it is called as oscillating charge. Okay. So we can say when these two are repeated continuously, then we can say oscillating charge. Oscillating charge in a conductor can produce electromagnetic fields or electromagnetic radiation. Okay. So finally we can conclude here, the source of electromagnetic field is a time varying current in a conductor, or we can say a moving charge with acceleration or deceleration can produce the electromagnetic fields, or oscillating charge in a conductor can produce the electromagnetic fields here. Okay. So simply if we compare the source of all these fields here, what is the basic element we require to generate electrostatic field or magnetostatic field or electromagnetic fields? Here basic element we require is nothing but charge. Everywhere you can see when charge is stationary, static electric field. When charge is moving with a constant velocity, charge is moving with a constant velocity, that will produce a magnetostatic field. Okay. Similarly, whenever charge is oscillating or decelerating or accelerating, okay, that can produce the electromagnetic fields. Okay. So for all these fields, the basic element we require is nothing but charge. Charge with a different states or charge with the different conditions can produce the three different fields. There is electrostatic fields, magnetostatic field, and also electromagnetic fields. Okay. Here important element we need to concentrate here is charge. Okay. So this is the introduction about the electrostatic field, magnetostatic field, and also electromagnetic fields. Okay. Now let me explain about charge. You know that charge is available in 4 different forms. Let me explain what are the 4 different forms of the charge. Okay. Then we will start with Maxwell's equations. Okay.